Good morning. Today we are going to discuss vector calculus, and in vector calculus it is just like your ordinary calculus, and the difference we will discuss differentiation of univariate functions. As you know what differentiation is, and I'm not going into the details of differentiation. What is differentiability? What is limit continuity? Those concepts we already know. And now we are going to discuss what is a Taylor polynomial. Taylor polynomial. A Taylor polynomial of degree n of f is a function from R to R, means it is a function from real number to real numbers. At x0 is defined as Tn of x is equal to sigma k equals 0 to n f of k into x0 by k factorial into x minus x0 raised to k, where f of k of x0 is the kth derivative of f at x0. Okay, and Taylor series, that means here Tn of x, that means this is the number n is equal to 1, 2, 3, etc. And if this doesn't terminate, then we have t infinity of x is equal to k equal to 0 to infinity f of k x0 by k factorial into x minus x0 raised to k, where x0, if in this equation if we are putting x0 equal to 0, then it will become f of k of x0 f of k of 0 by k factorial into x raised to k. So that is called Maclaurin series. So I will show you an example. For example, suppose that if you want to represent, say, f of x is equal to x raised to 4. Then, as per this is a function from R to R. That means you can take any value for x, and equivalent to that you get a value for x raised to 4. That is, this is a function from R to R. And here, see, Tn of x is equal to k equal to 0 to n f of k into x raised to 0 by k factorial into x minus x0 raised to k. Okay. Now we are going to discuss, say, now I'm going to have this at x equal to x0. Now I'm going to put this x0 equal to 1. Now in this equation I'm going to generate a Taylor series with respect to the point x0 equal to 1. Okay. Now say, what is f dash x? F dash x is equal to 3, not 3, 4x cube, and f2 dash x is equal to 12x square. Then f3 dash x is equal to 24x, and f4 of x is equal to 24, and f5 of x is equal to 0, and all subsequent derivatives will be 0. Okay, now when you are putting f of 1 is equal to, what is, if you put f is equal to 1, x equal to 1, what will be the value of x raised to 4? 1. Then f dash 1, what will be the value of f dash 1? Is 4. Then f2 dash 1, what is the value? f2 dash 1, that means 12. And f3 dash 1, f3 dash 1 is 24. f4 of 1, f4 of 1 is 24, and f5 of 1 is equal to 0. Now I am going to write this equation. Now I am going to have, say, f5, that means fifth derivative onwards it is 0. So I am going to take t5 of x. So I am going to put it like this. Tn of x means t5x is equal to sigma k equal to 0 to 5. Okay, k equal to 0 to 5, f of k into of x0 divided by k factorial into x minus x0 is 1 raised to k. Okay, here this is actually now the value of this is 1. That is equal to, if you are putting k equal to 0, what will happen? If you are putting k equal to 0, this becomes f dash f of 0. If you are putting k equal to 0 here, then f of 0 of f of 0, or this is not f of 0, f of 1 by k equal to 0 factorial into x minus 1 raised to 0 plus, when k equal to 1, this is f dash of 1 by 1 factorial into x minus 1. Okay, f dash of 1 by 1 factorial into x minus 1 plus f 2 dash 1 into x minus 1 the whole square by 2 factorial plus f 3 dash 1 into x minus 1 the whole cube divided by 3 factorial plus f 4 of 1 by 4 factorial into x minus 1 raised to 4 plus f5 of 1. f5 of 1 is 0. That means the next term will be 0. That means this is, what is f of 1? f of 1 is 1. That means 1 by 0 factor. That means this is f of 1 is 1, 0 factorial is 1, x minus 1 raised to 0 is 1. That means this is 1 plus f dash 1 is 4. 4 into x minus 1 plus, what is f2 dash 1? f2 dash 1 is 12. 12 by 2 factorial is 6 into x minus 1 the whole square plus, what is f3 dash 1? f3 dash 1 is 24. So equal to 24 into 24 by 3 factorial is how much? 3 factorial is 6. That means 24 by 6 is 4. 4 into x minus 1 the whole cube plus, what is f4 of 1? f4 of 1 is 24. 24 by 4 factorial. What is 24 factorial is 24. So 24 by 4 factorial is again 1. That means plus x minus 1 the whole raised to 4. So this is the expansion of x raised to 4 with respect to the point x0 is equal to 1. With respect to the point x0 is equal to 1. So this is the Taylor series expansion. This is very important. If you are given some polynomial, and if you have to develop the Taylor series around a particular point, you have to find out these derivatives and the value of the function, value of these derivatives at that particular point, and using this equation you can have this. That means if you expand and after that if you simplify, that you will get x raised this is x raised to 4. Okay, now we are going to discuss how f of, suppose that our equation is sin x plus cos x. Suppose that, see, this is the Taylor series expansion, and I am going to show you how sin x and cos x behaves as far as Taylor series is concerned. See, using Taylor series you can expand sin x plus cos x. See, now f of x is equal to, say, sin x plus cos x. Sin x plus cos x. That means this is a function from, f is a function from R to R. That means any real number here you can take, and sin x plus cos x is we can evaluate the value of sin x plus cos x. See, what is f of x? What is f dash f of x? Now I am going to develop this with respect to the point x equal to x0 is equal to 0. Now I am going to find out the expansion with respect to the point x0 is equal to 0. Now f of x is equal to sin x plus cos x. What is f dash x is equal to the derivative of sin x is cos x plus cos x is the expansion derivative cos x is minus sin x, thus so this will become cos x minus sin x. Okay, what is f2 dash x is equal to derivative of cos x is minus sin x derivative of sin x is cos x minus cos x. Then f3 dash x is equal to, what is the derivative of sin x is cos x, and derivative of cos x is minus sin x, this is plus sin x, and f4 of x is equal to, what is the derivative of cos x is minus sin x, that means this will become sin x plus cos x. That means initially we have sin x plus cos x, then afterwards f4 of x is sin x plus cos x, then f5 of x is cos x minus sin x, f6 is minus sin x, that means this will be repeated. Okay, this is repeating. See, what is the value of f of 0? What is f of 0 is sin 0 plus cos 0 is 1. Sin 0 is 0 and cos 0 is 1, that is f of 0 is equal to 1. What about f dash of 0 is equal to, f dash of 0 is cos 0 is equal to 1 and sin 0 is equal to 0, that means cos 0 is 1, sin 0 is 0, that means 1 minus 0 is 1. What about f2 dash 0? This is minus sin x, that means minus sin 0 minus cos x, that means minus 1. f3 dash 0 is equal to, f3 dash 0 is equal to minus cos 0, that means minus 1, this is minus 1. Okay, and f4 of 0 is equal to again 1. That means here I am expanding this using our Taylor series. That means t infinity of x is equal to sigma k equal to 0 to infinity f of k by k factorial, fk of 0 by k factorial into, what is that, x minus x0, that means x raised to k. So this is the expansion. I am going to have the expansion, that means this is k equal to 0. When k equal to 0, what will happen? K equal to 0, what is fk of 0? F of 0 is equal to 1, that means 1 into 1 by 0 factorial into x raised to k. X raised to k is 0, that means x raised to 0 plus. Next is when k is equal to 1. When k is equal to 1, what will happen? F of 1 of 0, f1 of 0 is 1. 1 by 1 factorial into, what is that? X raised to 1. 1 plus. Next is f2 dash 0, that means minus 1. Minus 1 by 2 factorial into x square plus, what is f3 dash 0? That means minus 1 by 3 factorial into x cube plus 1 by 4 factorial into x raised to 4 plus 1 by 5 factorial into x raised to 5 minus etc. This will be continued. Now I am going to group this. That means 1 by 0 factorial is 1, 1 by 1 into x raised to 0, this is 1 plus this is x raised to 1, this is x by 1 factorial plus minus 1 into x square, that means minus x square by 2 factorial minus x cube by 3 factorial plus x raised to 4 by 4 factorial plus x raised to 5 by 5 factorial minus etc. Okay, this is equal to 1 minus, I am going to group x raised to 0, x square, x raised to 4 etc. That means even powers of x. That means 1 minus x square by 2 factorial, 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus etc. plus x by 1 factorial minus s cube by 3 factorial plus x raised to 5 by 5 factorial minus etc. So this is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. This is cos x plus sin x. Cos x plus sin x. So cos x is the expansion 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus etc. And sin x is x raised to x by 1 factorial minus x square by 3 factorial plus etc. So that's all about Taylor series expansion of sin x plus cos x. So here we can write sin x is equal to, what is that? X by 1 factorial minus x cube by 3 factorial plus x raised to 5 by 5 factorial plus minus etc. And cos x is equal to 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus etc. Okay, so that is all about the Taylor series expansion of sin x and cos x. Okay, thank you.